It's Don here from the board. Thanks for coming along and checking out this video. So today we're going to be having a look at a DC power supply that I bought off Banggood. Now it's the Minleaf NSP605W DC power supply, and this video is not at all sponsored. I bought this on my own accord with my own money. Now the reason why I bought this is because I have a TS100 soldering iron, which it's a really old video that I did, but you'll see in that, and when I normally use it, I actually have it hooked up to a old external hard drive power supply, and that power supply is getting a bit old now, and the connection of the, not the socket, but where the cable goes into the brick is starting to work its way a bit and wobble, and I'm kind of concerned about its longevity. The other thing about that power supply is it's only a 12 volt power supply, whereas the TS100 can take up to 24 volts, which would give me a faster heating rate and more wattage behind it, so I can solder for longer, faster, without waiting for it to come back up to temperature if I'm doing a lot of joints in a row. And the second reason why I decided to buy a DC power supply is because I've got more mad scientist crazy ideas out there, and I thought I'd get something that would be a little bit more suitable compared to what I had previously. So before we actually open up the box, because I've got it here in front of me, I just want to have a look at the actual listing so we can see what we're expecting to see, hopefully, and then we can, gauge what we've actually got. So this is what the unit is. It's about 60 US. It's a relatively small unit. It has coarse and fine voltage and coarse and fine ampage control. It's got your standard banana plug plus and minus with an on-off button. Now I did order it with an Australian plug because I am in Australia. It did come pretty quick. It came within a week from ordering it. The only thing is the box has a rattle to it, so I'm kind of worried because, and you'll see when I switch over to the desktop, when they packaged it, they didn't put anything on it for protection. They literally slapped on the shipping label in Melbourne, this came via Melbourne, and handed it off. So I wasn't very impressed with that. Now this particular model has already had some reviews from a couple of people around the place, different language, but it's meant to be 60 volts, 5 amps. So 60 volts, 5 amps is exactly what they've got here, 300 watts. 230 volts, 240 volts for us, that's fine. Minus 10 to 70 degrees is fine. If we're at 70 degrees, we'd be in trouble. Now 40 degrees working temperature, some days in summer we can crack that, but if I was going to be doing any hot works, I'd probably have the air conditioning on anyway. So it seems to be pretty straightforward, and I went with a 5 amp unit because Australian power points are generally rated for 10 amps. There was a different version that was a 10 amp supply, and I didn't want to potentially draw and overload the entire power circuit, which would have shut down like all of the power points in this room and half the unit. So it drawing 5 amps and blowing the fuse in it would have been just fine compared to trying to draw 10 amps, which could have tripped the circuit first before it drew and blew the fuse on board the actual power supply. So that was the decision behind it, and I really don't expect that anything that I'm going to be tinkering with is going to pull 5 amps, because 5 amps is a crazy amount of power. So that's what it looks like, and looks pretty straightforward. Hopefully that's what we're going to see in the box. So let's switch over now to the desktop, and here is the unit. The tape seal is unbroken, that's how it came, and you'll see, as I mentioned, it says 240, 60 volt, 5 amp, 1.6 kilograms. The actual company is in the Netherlands, which I found really, really interesting. However, it was made in China. Now on this side, I'm not kidding, but like that's literally what they did. They slapped on the shipping label on the box, and off it went with the courier. No external packaging, no protection, or anything of the sort. So it does, like, there is things that are moving around in there, which probably can't hear it, but my wife and I were listening to it earlier when it got dropped off, so hopefully it's all in one piece. The other reason why I'm also filming this, besides reviewing, is because if I need to make a warranty claim because this doesn't work, I've got this fully on video. So it always pays these days, if you're ordering stuff online, to potentially film the opening of it to prove as best you can that it was defective upon arrival. You know, you just don't want to be in a situation where you've put in good money and you've got something that's not in the condition you're expecting it. And, well, we can see there's not a massive amount of protection. There is some sort of gap in between the packaging there. It's got that high density foam, which is fine. We've got the Australian plug. Is that? Yeah, okay. I was just thinking it looks awfully small because that's tiny compared to a standard Australian plug size, but that'll work. And I didn't realize it actually came with these, which is really cool because the pictures didn't indicate. Maybe that was what was rattling. So that's cool. So here's the actual power supply itself in the foam. We've got a user manual. We've got a QR code. So some QR codes there. And there was a little piece of cardboard which probably was also part of what was rattling around and bouncing in there. So quick look at the manual, some specifications, loosening the terminals and putting in those forked connectors. So it says setting voltage operation mode. You can adjust to desired output voltage and current, setting the current limit. Temporarily short the plus and minus terminals with a test lead. Rotate the coarse voltage to have the CC indicator lightened. Okay, so that's really interesting. You can actually set the maximum current that it's allowed to pull, but that's okay. I'm not going to bother with that because what I'm planning on using shouldn't really be too much of an issue, I hope. Right, now what I do have is I've got a multimeter here, so I'm planning on plugging this in and then we can actually see how accurate it is. I did see in another video that you can technically open this up and calibrate it, but obviously it's not covered at all in the manual. There's no calibration at all in the manual. So you kind of need to know what you're doing, which I don't know if I necessarily have that. So this is my TS100. I'm not actually going to plug it in, but I just want to show what I'm talking about, because if you're not familiar with it, it's a TS100 mini soldering iron, and the TS80 also, but the TS80 has a USB-C connector on it rather than the DC5225 connector, which I could make a connector to go straight into this particular unit. Right. Let's take the foam off and have a look. It is actually quite small. It's super compact. I've got a ruler here so we can see the unit itself is only about 12.5 centimeters high. It's 7 centimeters wide and it's 21 centimeters deep. So we can see our coarse and fine voltage and amps. We've got our banana plug connectors, which I wanted to know if there was a hole, which it does. So the thing is, I don't have any banana plug connectors or any fork connectors, but the post does permit cross through, because there's the hole there, if it'll focus. So I can actually feed a wire in and then I can just screw down and pinch that in, which is excellent because that's kind of what I'm going to be relying on. And a really solid push button. Now on the back we can see that there is a fuse compartment here, 250 volt fuse, and it's already preset to the 230 volt setting, which technically you should be able to flick that down and it'll be 115, which I definitely do not want to operate in because it'll blow up straight away. Now, I should be able to use a screwdriver. There we go. And it's pre-fitted with that fuse, which is great. So that should blow at 5 amps or greater than 5 amps, 250 volts. Right, so let's move this. Let's see how long this power cable is. Now, you've got to make sure that you're working as safe as you can, because even if you're working at DC, 60 volts is nothing to laugh at. It'll still hurt. It'll still hurt if you get zapped. Okay, so that's nice and firm into the back. The cable's got a good length to it. It's over 1 meter, which is good. So it will actually reach my power point. Okay, so that is in, and $61.5. It's probably a bit high for where I want to be. So the coarse all the way down. It's very slow reacting. I've dialed it all the way down and you can see how slow it is to actually drop. Wow, that is super duper slow. That potentiometer must have a very slow response. Come on, you can do it. 0.4, 0.3. Alright, let's take the fine all the way down as well. So there's no markers on these, so you don't really know where you're actually at. So there's constant current is on as opposed to constant voltage. So it's reading 0.1, 0.0. So right now I'm going to set that down. Hopefully I won't blow up my really cheap multimeter here. Okay, make sure I've got my plugs in. Black should be ground and comms, and we've got 5 amps, 500 volts max, 500 milliamps maxed. So we shouldn't really go very high with, let's just go with the standard one to start with. And voltage, DC is on this side, and we'll go to 200 since this unit should only be going up to 60. Alright, so we can see that's reading 0.0. Actually, you know what? We're going to use what they've got. I'm going to turn that off. Wow. So when it's plugged in, oh, hang on, I'm just going to turn that back on. So it has some starting voltage that you have to be aware of. And then when you turn it off, it takes a number of seconds for its capacitors to drain out. There you go. So there's quite a delay on that. You just need to be aware of that. If you have something that's plugged in, there is actually a significant delay on when that shuts off. Alright, so let's go with using these forks, and then I can clip my probes onto them. Then red to red. Wow, these alligator clips are really strong, which is not a bad thing. Right, so now we can turn that on, and we can already see that we got some values there. So it's reading 2 and 2, 1, 0. So between 0, 0, 0, 1, okay, it's fallen off. Right, so coarse values, let's start dialing it up. Okay, so it's not going to give me any coarse voltage without a little bit of current, I guess. There we go. So we're back onto constant voltage. And right, so let's take it to, well, it says 5.3. Now we're reading 5.3, 5.4, 5.3, 5.4. It's not bad. It's not bad. If I dial that, well, take up to 5.4, so it's just ticked over 5.4. It's pretty stable on 5.4. Let's go up to, say, well, let's take that fine up and then midline it. We'll go up to, wow, this is really frustrating. The coarse settings jump heaps. Okay, so I'm going to take that down to 12.0. And we're sitting at 12.1. So, you know, the error there is not too bad. I mean, reading 12.0, 12.1. If I go up to 12.1, it's 12.2. Right, so you kind of just need to be aware that it is adding a little bit of extra there. And if I go up to, say, maybe let's take it up to 24. Okay, 24.0, 24.1. So it's not too bad. It's not too bad. Right, now if we take it all the way up to slowly, 39.9, we're reading 40. So you probably need to think about that. Depending on if you need something that's got high precision, you got to take into consideration that it's adding a 0.1 volt on there somewhere. And let's go all the way up to 60. Now we did see it went over 60 before. Oh. Okay. We got it at 59.9, 59.9, 59.8, 60, 61. So it's definitely doing the job. Just accuracy wise, it's holding okay. It's holding okay. Alright, so let's just take it back down. Let's go down to, let's say, 12 volts. It's kind of where I want to work at. We're back down to 12. So now what I'm going to do is I'm going to turn that off. You can see a number of seconds before it actually loses everything. And then my multimeter, which is very slow in its response. And let's take it up to amps. So it's still got some trickle of voltage that you can see. It's still trickling voltage, even though the fact that this is off. Alright? So you got to be careful about that. It's still trickling voltage, despite the fact that the unit is off. So let's take it to 5 amps. So 0 amps. Okay. Let's change the plug to our 5 amp max. I don't want to go anywhere near 5 amps because I don't want to blow the fuse on this because I don't have a replacement fuse. Right, so power on. I can hear the fan now going on it. Maybe? No. There's something going there, but we can now see it's pulling current. 0.22, 0.23, right? So let's go and take it up to 1 amp. 1.02, 1.02, 1.01, 1.02. Okay, so, it's actually doing okay. Although it is making noises. And it's not the fan. The fan hasn't kicked in. The fan isn't... I don't know if you can hear that. I don't know if that's normal. But that's just something to be aware of, that it's making noises. Whether it should be or not, I honestly couldn't tell you. Nobody's made comments in the actual reviews about this unit, about the noise. So it could be quite normal. I don't want to go too high with it, but let me just take it down to, say, 0.1 of an amp. There we go, 0.1 of an amp and 0.11. Accuracy wise, I think it's okay. For what I want to do, I'm not doing anything particularly super sensitive that requires a high level of calibration. If I'm going to run the TS100, I'd probably run it at maybe 20 volts, 22 volts. I don't need to run it right at 24 volts in case it does tick over, and then I run the risk of damaging the actual unit. Whereas my mad scientist idea is a 12 volt device. So it's a little 12 volt motor that I've actually got here. So you can see it's a 12 volt. So I don't really need to be running at 60 volts, and this thing is only meant to draw about 500 milliamps or so. So it's not really that big a deal. Now straight away the amps have dropped all the way down with the power off, all the way down to your milliamp level. It's reading nothing, which is a lot better than when it was holding voltage in its capacitors. Okay, so that's a look at this Minleaf power supply. Just having a look at the model number, the NSP605W, a 300 watt unit that will do 60 volts and 5 amps. Of course, I'll have a link below if you want to go check it out yourself and you think it could be something that's useful for you. Footprint wise, I'm pretty happy with it, and if I have long enough cables, then it doesn't even have to sit on my desk. It can sit off the side. Once I've got it dialed into the voltage that I want and I'm happy for it to be stable, then I can hook it up to whatever it is and away it goes. Well, that's it. Thank you very much for checking out this video. If you like this review and you want to catch up with any of the other crazy things that I do on this channel and my harebrained mad scientist ideas, please of course hit that subscribe button and the bell button to let you know when my next video is out. Thanks very much for coming along and checking out this video, and of course, as usual, until next time, happy clacking.